Myself, Dr. Bhavna Agrawal from Mathematics Department. As we have already discussed before, linear differential equation and problem-based linear differential equation. Now this video is on non-linear differential equation. Non-linear differential equation, also known as Bernoulli's equation. The standard form of non-linear differential equation is dy by dx plus py equals to qy to the power n. Here two variable is being used as x and y. Y is dependent and x is an independent variable. We have earlier discussed about the linear, that coefficient of dy by dx must be 1. It's okay. And p coefficient of the dependent variable from second term, that is value of p must be function of x only. And right hand side of equal to must be the function of x, which is a value of q. But here y to the power n is getting restricted. That's why this given standard form is in non-linear form. Let us see. Now to convert non-linear differential equation to linear differential equation, we simply multiply both the side of the given equation to y to the power minus n. That is y to the power minus n dy by dx plus p y to the power minus n plus 1 equals to q. Here y to the power n was getting restricted. That's why we have multiplied by y to the power minus n. Now substitute the value of y to the power minus n plus 1 equals to v so as to make the coefficient of dy by dx to 1 and differentiate this. We get minus n plus 1 y to the power minus n dy by dx equals to dv by dx. Now dv by dx plus 1 minus n p dot v equals to 1 minus n q. Let this be equation 3. Now compare this equation 3 with a linear differential equation of a standard form dy by dx plus py equals to q, where p and q function of x. Coefficient of dv by dx is 1. Yes, value of p and q over here is function of x. Thus, this equation 3 is in linear differential equation form in V. Integrating factor I dot f is equals to e to the power coefficient of V, that is 1 minus n p dx. Now the solution is given by dependent variable, that is v, into I dot f equals to integral of 1 minus n q into I dot f dx plus of c. Now substitute the value of I dot f from above. We get e raised to power 1 minus n integration p dx equals to integral of 1 minus n q dot e raised to power 1 minus n integration of p dx integration with respect to dx only plus of c. Now at last replace v in function of y. Take v is equal to y to the power minus n. E raised to power integral of 1 minus n p dx equals to integral of 1 minus n q e raised to power integral of 1 minus n p dx plus of c, which is the required solution. Thus what we have concluded. Conclusion is that when a given equation is in non-linear form, we'll convert to its linear form by multiplying both the side of the given equation, which is of non-linear form, by y to the power n. As soon as we get to convert to linear differential equation form, we'll solve it by the following methods. That is integrating factor, this one. Final solution will be this, and at end it's this. Thank you.